Okay, welcome to video 7.1. We're going to talk about arithmetic versus geometric sequences. These are two sequences that we're going to talk a lot about in this unit. So a sequence is just a function whose domain or inputs is the set of counting numbers starting at 1, 2, 3, 4, and so on. And the terms of the sequence or the outputs will have very specific patterns that we'll notice. So in the first example, consider the sequence below. If we represent the sequence with the letter A, then find each of the following. A of 3. Well, if we look here, the first term is just the first one that we see. So this is the first term. Then we have 8 as our second term, 16 is our third term, and so on. So when we ask for A of 3, that's just asking for the third term. When I look at the x of 3, then what is the term? So input 3, out comes 16. And the next one, A of 1, that's 4, that's the first term. And then A of 7, that's the seventh term, is 256. And then we just put those in for A of 1 and A of 7. So that shows us the 4 plus 256. When we add those together, we get 260. So that answer is 260. This one is asking us for n. So now I don't know what term it is, but I know that the number that's supposed to be the output is 128. So 128 happens when the input is 6. So the n value here would be 6. And then here's just another way of writing it, this subscript here, a sub 2. A sub 2 is just still an input. This is like A sub n. We've got a 2 here, so the second term is 8. Okay, so sequences just use a different notation compared to our functions that we've talked about in the past, but they work exactly the same way. So we still have our inputs and outputs. A of n is just now going to be written as A sub n. It's the same idea, same thing. It's just that we have a new way of writing it. So example 2, a function is defined by this equation. This is a function. So just like we've talked about in the past, we've got inputs and outputs. We're just using a and n instead of like f of x. So a of n equals 6n plus 3. Well, now I see a 5 instead of n. So everywhere I see an n in my function, I'm going to replace it with the input of 5. So a of 5 equals 6 times 5 plus 3. Then we can put it in our calculator and we get a of 5 equals 33. The next one is asking us for a n this time if a of n equals 18. So now in place of the a of n, I'm going to put the 18 in place of the whole thing, a of n. Then we can solve just like we've always done. I want n by itself, so first subtract 3 from both sides. And then when we divide by 6, we get our answer, which is n equals 15 divided by 6. So we can always plug in our inputs and get out our terms. So they're very similar to the functions that we've done in the past. Okay, example 3 here. A sequence is defined by this equation, a sub n equals 2n minus 1. Find a sub 4. Same idea. The 4 is in place of where I used to have an n. So now everywhere I see n, I'm going to replace that n with the number 4. So I plugged in that 4, a sub 4 equals 2 times 4 minus 1. Make sure that you show that this is a subscript written down low. So then I have a sub 4 equals 7. So in went 4, out came 7. This one asks which term has a value of 23. So now that means that this is going in for the output. This is the output instead. So we're going to put this 23 in place of the a sub n, the whole thing. It's like a y value, an output is the value of the term. So I put in the 23 as the output. 23 equals 2n minus 1. So then I add 1 to both sides. That will give me 24 equals 2n. And then we can solve for n by dividing by 2. 24 divided by 2 is 12, so n equals 12. So my answer is 12 equals n. Now this one says explain why there will not be a term that has a value of 40. Well, if we plug in 40 as the value, we can solve just like normal. So 40 plus 1 is 41. Now when I look, if I try to divide 41 by 2, I get a fraction. And remember we talked about these are the counting numbers, so we can't have a fraction, so that is the reason. So I just wrote the term cannot be a fraction, so none of the terms will have an output of 40. And this is the difference between sequences versus the equations. Okay, we'll talk about this more tomorrow. Have a good night.